So good morning, everybody. I am Pascal Friche. I am responsible for the business software marketing at GFMS, and I am very pleased to showcase you what we are exhibiting this year. So the goal of this booth, the digital corner where we are now, is to exhibit the technology switch that we will apply at GFMS. So today we are selling to our customers what we call a client-based application, and we are showcasing here the future where we will be able to exhibit the whole web-based access and cloud-based solution. So what we showcase here is the fact that we have plenty of customers where they have unconnected machines. And the beauty of the web-based access is that even with an unconnected machine, the customer will benefit of ticketing, of conferencing, and video. So that means the customer will be able to have also the possibility to send out service requests, to send out chat, and to get an answer from our customer service. So that means in our environment, if we move along to the technology, then from 2017, we started to implement what we call a AirConnect box, allowing the customer to be connected to his network. So when we said connected to his network, that's the intranet of the customer, and allow him to have live remote access to his machine as well as data access. So that means these features will help the customer to transfer data, to read data like software update, firmware update, as well as also get in touch with his HMI. He will be able to control the HMI, and he will be also able to tune the machine remotely through his own intranet. Moving along to our new technology, what we call edge computing, is allowing the customer to connect his machine through the IoT, Internet of Things. So that means the data will be pushed in the cloud storage as well as in a cloud application. By doing that, our customers will benefit about performance analyzer, so he will be able to see the machine KPIs live, and he will be also able to dig into issue if they have, and also the historical data that the customer does have about all job performing. On top of that, we are also introducing the process inspector, and the process inspector is also using the cloud storage and cloud-based application. So that was my brief introduction about our web cloud-based solution, and now I will move to Ivano Gazzetta, who will present you the process inspector.
So thank you, Pascal. Yes, I'm Ivano Gazzetta, and I will show you now Process Inspector, which is a new tool that uses the data which are provided by the machines and extend the functionality of the machine, bringing new added value for the customers. Typically, on the screen here, you see a drawing that looks like a CAD/CAM or a 3D graphic, but it's not coming from a PC, it's really coming from the data that were recorded on the machine. Typically, to generate this picture, we were grabbing the XYZ position of the machine and the quality of the sparks that were used to erode this part. This part represents a typical stamping plate done by wire EDM machine. And while we were doing this, we have recorded a lot of data. And here I can show you typically how the full process inspector looks like. We have on that side all the operations as they were programmed on the machine to execute the part. On that side, we have all the events that were generated by the machine, like errors, alarms, and so on. And on the lower side, we have the signals that were recorded. Typically, here you see main information which is critical for the quality of the part, like temperature, quality of the dielectric, and so on. Typically, with the tool, we will aim to help you to ensure that every part you will be doing are better than the previous one. We have 3 areas where we can bring value on that. Typically, the first one is to accelerate inspection. Let's take the situation where during the part, like here, there were errors generated. Then the question is, does this affect the quality of my part? And if yes, where should I do the inspection? To accelerate this inspection process, here with the tool, you have simply to click on any of the error messages, and you will see on the 3D this cursor that highlights where this was recorded. So you know that you have to go directly there to do the inspection. So the other situation that could happen is that the quality of the part is not the one expected. Typically in this picture, we can see in this portion of the part, we have the quality of the surface which is not as expected, as good as expected. So for this, again, we can use the tool here, zooming on this very specific position using the 3D graphics. I can select the zone that was concerned by the problem, and I can rewind the story by looking at the signals and figure out why the quality was not the good one. To help you on this work, we have prepared for you profile of signals that are interesting for the main typical situation, like quality of the surface is not okay, or the precision of the part is not as good as expected. And with these kind of profiles, you will be able to display different types of signals that will help you to figure out what was the problem that was generated. And finally, with the tool, we have also the best traceability tool that you can have. During the execution of the part, if an operator changes the parameters of the machine, they will be recorded also, and if you have to redo the part later on, you can rewind the story again, figure out how you were doing this part and reproduce exactly the same thing. We have also the possibility to easily download the job report by simply clicking here. You open a file on your browser and you can extract it. And it's a general view here. You can do this for all the machines in your shop floor, and every single job is recorded, and you can rewind the story very long in the past. So with this new tool, we are convinced that we will bring you new dimension. We will provide you a way to extend the functionality of your machine. So this concludes my presentation, but it's just the beginning of the story. We are developing now new tools that will come soon and will also enrich furthermore the potential of your machines. Thank you.
Hello again. Now I would like to show you, as was explaining before, the capabilities of our analysis tools, which we call the performance analyzer. So the performance analyzer is a dashboard, and the dashboard is able for the customer to dig into the historical data of his machine, as well as to understand how the job is performing. As you can see on the screen, we have today 3 KPIs which are pre-computed from our machines. All our machines are speaking the same language, so we developed for that an OPC UA standard interface that are equivalently equal for all the technology that we are selling. So that means a customer who would like to extract data from our machine will use the OPC UA standard interface, and we are using this data as well to feed our performance analyzer. As you can see on the screen, we have 3 KPIs pre-computed, which is the setup ratio, the technical efficiency, and the utilization efficiency. In this showcase here, we did use a simulation data to be able to showcase the following scenario. As you can see on the screen here, we selected 2 EDM machines, And from the month of March, we do have a robot added to one of the machines. The result of that, we showcase the fact that the setup ratio will be decreased by the machine who are coupled with a robot, and as the benefit for the customer, that will be the utilization efficiency. So as you can see, the utilization efficiency is moving from 93 to 96.5% as an average. On top of that, this tool is also good for the customer to analyze what was the historical issues or where he can improve also the usage of his machine. So what I would like to showcase here is the way of the process and part inspector is possible to do this analysis. So here, if I select this point here, I will be able to select a job in the historical data, like we showcased before in the process inspector, and in the analyzer, the performance analyzer will be also able to showcase what was done on each job. So as you can see here, we have now a job timeline where you can really zoom on the issue, and by doing that, you will be able to zoom exactly in the time frame that you are looking for, and we can start to do some analysis. So what is important to understand for the customer is when the machine was out of service, when the machine was waiting, and the reason why. So by doing that, we selected now the time frame, and as you can see here in the pink, we have exactly the low level pressure at that time that is here showcased. So by doing that, the customer have the possibility to really understand how the machine was performing. So on top of that, what we can do also, if I'm going back to the KPIs overview, we can also highlight two other KPIs which are the allocation efficiency as well as the availability of the machine. And both parameters are using the planning that we can also set into the performance analyzer to be able to have in the calendar of the machine exactly how the machine will behave. And also, due to that, we can adapt this percentage and read it as a result. So this is a brief overview about the performance analyzer, and thank you very much for your attention.